Let's imagine a situation in which our application is pulling employee data from the database, and then it is stored as a list of person objects in the memory. A person is just a type which had few fields: first name, last name, contact number, date of birth, and it also had a sayHi method. Once we have loaded this data, our requirement is to count the number of employees who were born after the 1st of January 2000, and if there is an employee with the name Bob amongst them, we want to invoke the sayHi method for him. First of all, how do we filter the employee list so that we can operate only on those who should be applied to this requirement? With the removal method, we could remove all employees from the list who were born before the January 1st, 2000. But this approach would modify the existing employee list, and we would have lost the data for those employees. This approach is bad, so maybe instead we could create another variable to which we could assign only those employees who fulfill our predicate. In our program class, I have created the following getEmployees method, which returns a list of person type objects, imitating a database select statement. It simply defines 7 person objects, and 4 of them have the date of birth field value greater than the January 1st of 2000. In the main method, I have created an employee variable and assigned the result of the getEmployees method to it. Let's create the second variable, which will store those employees who were born after the specified date. So list of person, let's call them young employees, is equal to new list of person. Now we can iterate over the employees from the initial list, and if a given employee matches our condition, we can add him to the young employees collection. The simplest way to iterate over those employees is just to use the for each loop. So for each person employee in employees, and with the if statement we will check if the employee date of birth value is greater than the new date time 2000 January 1st. If yes, we want to add him to the list, so young employees dot add employee. In this way, the young employees variable will contain 4 objects, 4 employees who match that condition. I will console count so that we will fulfill the first requirement, which was to display the count of employees who were born after January 1st, 2000. So console write line, young employees count, young employees dot count. If I run the program, we'll see that the console displays the correct number, meaning that our first requirement is completed. And how do we get the employee with the name Bob from this list? We'll have to declare a person variable, and then iterating over the employees from the young employee list, we'll have to check if the given employee has that Bob name, and if yes, we can exit the loop and invoke the sayHi method. So first of all, we'll need a person variable to store that potential Bob employee. So person Bob is equal to null. And now we can iterate over the employees from the young employee list. So again, for each person, let's call him young employee. In young employees. And now we will check if the young employee first name is equal to Bob. And if yes, we'll just say that Bob is equal to the young employee, and we will break the loop. After the loop is completed, you can check if Bob exists And if yes, you can invoke the sayHi method. So if Bob is not a null value, we will say that Bob say hi. And if Bob is not found, so it is a null value in the else statement, we will just construct writeLine Bob not found. Once we run the program, we have the young employees count displayed and also Bob said hi. We managed to fulfill both requirements using two for each loops and if statements. In a real-life application, this kind of a requirement, like filtering, selecting, or even counting elements based on some predicate, is very common. Using loops and writing the logic in if statements on a bigger scale would create very rigid and hard to maintain code. So how do we approach these scenarios? The good news is that in .NET we have something called LINQ. LINQ is basically a set of extension methods for the I-enumerable interface, which provides lots of the functionalities that we might need in our programs. Covering them all in details would be a great topic for another course. To give you a brief example of LINQ extension methods, we will rewrite the existing code in our main method. First, we'll have to import it to our file. So at the very top of the program.cs file, I will add the following import statement using system.linq. Now let's start refactoring from the first for each loop. In this loop, we wanted to get only those employees where their date of birth value was greater than January 1st, 2000, which meant that they were young, and then we assign them to a new list. Using LINQ, this code could look like this. Instead of the loop, we'll just invoke the where method on our employees, to which we'll pass a predicate. Let's call it employee is young for now. And then we'll convert the result to a list like this. Now the code looks much cleaner than the for each loop and the if statements. The where method is one of the extension methods from LINQ, and based on some predicate, in our case that predicate is called employee is young, it returns a new collection with those elements which match the predicate. Then the returned collection can be converted into a list with the toList invocation. The employee is young is just a predicate for the person type. And as we mentioned previously, predicate returns a bool value, so let's implement that predicate. So bool employee is young, which will take a person, let's call it employee as the parameter, and from this predicate we will return the following expression. So employee get date of birth is greater than new datetime 2000 January 1st. Moving further with the refactor, instead of the loop and searching for Bob, we will use the FirstOrDefault extension method from LINQ. So now Bob will be equal to young employees dot FirstOrDefault, and here we will need a separate predicate. For now, let's just call it employee is Bob. And here the employee is Bob is a predicate which will determine if the given employee has the name equal to Bob. So let's implement that. Bool employee is Bob person employee, and we will check if the employee first name is equal to Bob. The FirstOrDefault method will return either a null value if any of those items didn't match the predicate, or the first one which did match the predicate. So the behavior is the same as we had with the for each loop. In this way, using LINQ and predicates, we managed to get rid of the loops and if statements which we previously had. I will just run the program to make sure that it works in the same way. Young employee count is still equal to 4, and Bob Smith said hi, so that's correct. In the next clip, we will see how can we simplify this code even more using lambda functions as our predicates.